Hi, welcome to this session, and in this video I will be talking about how to find out the trigonometrical function's value for some specific angles. So let me quickly start with an easy triangle first. So what I plan to do is I'm drawing an isosceles right triangle and I would like to find out the value of the trigonometrical relationships for them. So if it's an isosceles right triangle, then this one angle is 90 degrees. Let's call this triangle ABC, where point B is 90 degrees. AC is the hypotenuse. And since it's an isosceles triangle, so the two sides are equal, so the two angles will also be equal. Each angle is equal to 45 degrees. Now, in isosceles triangle, two sides are equal. If we can call them each with length equal to x, we can find out the length of hypotenuse using the Pythagoras theorem. That comes out to be x square root of 2. Now we can quickly find out the values of those trigonometrical functions. For example, let's call this particular angle theta. So in this particular case, we can say sine theta, which is equal to sine 45 degrees. Sine 45 is defined as perpendicular over hypotenuse, or we can say the opposite over hypotenuse, and the opposite here is x, while the hypotenuse is x root 2. So sine 45 becomes 1 over root 2. That's the first thing. Similarly, if we have found the sine 45, we can also find cos 45 degrees. So cos 45 degrees becomes base over hypotenuse, or we can say the adjacent over hypotenuse, and the base here is x, considering this angle theta. So once again this ratio becomes x over root 2, which is 1 upon root 2 again, which means we can see that sine 45 is equal to cos 45. Now we can also find out tan 45 degrees. Tan 45 degrees is equal to the perpendicular over base, or we can say the opposite over adjacent, and the opposite and adjacents are both equal to x in this particular case. So tan 45 becomes 1. So this way we have found the trigonometrical relationship in case of these three things, and sine, cos, tan can be converted into the cosec, sec and cot respectively. So similarly we can find out the value of the other functions as well. That means this leads us to that cosec 45 degrees, which is equal to 1 over sine 45 degrees, will be equal to square root of 2. The second part leads us to sec 45 degrees, which is equal to 1 over cos 45 degrees, and that will be equal to again square root of 2. And the last one will be the tan 45 degrees, which is equal to 1 over cot 45 degrees, and therefore cot 45 degrees also becomes 1 over 1, that is equal to 1. So this is one particular triangle in which we have found all these relationships. Now in the next page I would like to just draw another triangle, and then we will combine the entire angles. So let me take you to the next triangle. In the next case I would like to draw a triangle of the sides such that the angles in the triangle are recorded as 30 degrees, 60 degrees and 90 degrees, because these are the usual angles that we need to find in case of various triangles. So now let me quickly draw another triangle here, and this triangle is assumed to have the vertices represented as P, Q, R. It's also a right angle triangle, and let's assume that we are calculating this angle to be a 30 degrees, and now this angle is 60 degrees. Now we need to find out that what are the values of various trigonometrical functions in this particular triangle. So in this particular triangle we need to first of all understand that how do we find out the ratio of the sides, because if we knew the ratio of the sides then we would be able to answer this question. So let me quickly make another construction here, and let me make an equilateral triangle, because equilateral triangle gives the genesis to this 30 degrees, 60 degrees, 90 degrees triangle. So here I am drawing an equilateral triangle which has all the three sides equal. In this equilateral triangle, let's assume that we drop a perpendicular from one of the vertex on the base. Then due to the symmetricity we can say that these two bases will have the equal measure. We can prove them to be equal using the Pythagoras theorem as well. And let's assume that these sides are a each, then this part will be a by 2, a by 2. Now using Pythagoras we could have proven that these two parts are equal, because we have now these two right angle triangles here, and in both the right triangles the hypotenuse is represented by A and the perpendicular is same, therefore their bases should also be same. So now we have an equilateral triangle, and in equilateral triangle each angle that we know is equal to 60 degrees. But since we have divided this equilateral triangle into two equal halves, so we can also see that the angles at the top 60 degrees will be divided into two equal parts, and each angle will be equal to 30 degrees. So this is where this 30, 60, 90 degrees triangle is coming from. Now if we were to calculate the height of this equilateral triangle, we can say the height will be equal to square root of A square, which is hypotenuse square, minus the base square, which is A by 2 square. When we simplify this, it becomes square root of 3 by 2 of A. So that is where the ratio of the sides comes, which means if the side opposite to 30 degrees is A by 2, then the side opposite to 60 degrees is root 3 times of A by 2, and the side opposite to 90 is 2 times of A by 2, which means the ratio of the sides in case of any 30, 60, 90 triangle becomes this way. If the side opposite to 30 degrees is taken as x, which I am taking as r cube, then the side opposite to 60 degrees will be x root 3, because we can see in the adjacent triangle we have proven that the side opposite to 60 degrees becomes root 3 times of A by 2, and the side opposite to 90 degrees will become 2x, because it's twice the length of the smallest side of a 30, 60, 90 triangle. So now we have been able to find out that what is the ratio of the sides in case of a 30, 60, 90 triangle. Now that we have all these things available, we can also find out the trigonometrical functions and their values. For example, let's consider this particular angle as theta for our discussion. Then we can say that sine theta, which is equal to perpendicular over hypotenuse, or we can say the opposite over hypotenuse. Let me just make sure that if we are considering this angle as theta, then this becomes the opposite or the perpendicular, and x root 3 becomes the base, or we can say the adjacent. And now the opposite is x, the hypotenuse is 2x, so the ratio becomes 1 over 2, which means now we have that sine 30 degrees is equal to 1 over 2. Now that we have sine 30 degrees, let's quickly calculate what will be the value of cos 30 degrees. Now for cos 30 degrees, we can see that it's equal to base over hypotenuse, which can also be represented as adjacent over hypotenuse, and adjacent we know is equal to root 3x, so x root 3 divided by 2x, so that ratio becomes root 3 divided by 2. Similarly, we can find out tan 30 degrees as well, and tan 30 degrees, because tan theta is equal to perpendicular over base, or we can say the opposite over adjacent. So we can once again calculate it, opposite over adjacent, opposite is x, the adjacent is x root 3, so it becomes 1 over root 3. Now we can also verify that sine 30 over cos 30 should be equal to tan 30, so 1 by 2 when divided by root 3 by 2 becomes 1 over root 3, so that way also we can verify. Now we have been able to find these three relationships for the angle equal to 30 degrees. That means we can also find out that cosec 30 degrees will be 2 over 1, reciprocal of sine 30, sec 30 degrees will be reciprocal of cos 30, which is 2 over root 3, and tan 30 will be reciprocal of cot 30, that means cot 30 will be root 3 over 1. Now another thing that we would quickly add here is that using that we can also find out everything, every trigonometrical function for the angle 60 degrees. And for that, let us assume that the angle here that we are considering theta is 60 degrees. If we consider this to be a theta, then we must understand that the side opposite to that will be opposite, and this side will become adjacent, while the hypotenuse will remain as it was, that is 2x. So let's quickly calculate the other three trigonometrical functions, which means if we have to find out sine 60 degrees. Now sine 60 degrees, according to the same principle, perpendicular over hypotenuse or opposite over hypotenuse will be opposite now is x root 3. So that becomes x root 3, while the hypotenuse remains to be the same value, that is 2x. That means sine 60 becomes square root of 3 divided by 2. Now that's one way. Similarly, if we want to find the cos 60 degrees, we can use the same principle, and we can say that cos 60 degrees is equal to the base over hypotenuse or adjacent over hypotenuse, but the adjacent or the base in this particular case is x, while the hypotenuse is equal to 2x. So the ratio becomes 1 over 2. And similarly, if we have to find out tan 60 degrees, we can once again use the same principle, that is equal to perpendicular over base, and perpendicular, which is opposite, is x root 3 in this case, while the base is equal to x, base is same as the adjacent, and the ratio becomes equal to root 3. So that ways we have been able to find out all the trigonometrical relationships for the angle 30 degrees, 60 degrees, and for 45 degrees that we showed on the previous slide. And now in the next video I'm going to summarize all of them and then make a table of all these trigonometrical functions. But I hope you understood that where exactly are these values derived and you enjoyed them. Thank you so much.